Good evening, everyone, and welcome to today's MDS webinar. To our joining members, it is wonderful to see you again. And to those new to our community, we are excited to have you join us. MDS isn't just a simple community. We consider ourselves to be a family of passionate data scientists and IT experts, where we come together to share our learning journey, support each other's growth, and celebrate our shared projects and achievements. We have many exciting initiatives designed to spark your curiosity, and one of them is MDS Talks, where we bring in experts from the data science field or any IT field to share their insights and experiences with us. MDS Talks program is an opportunity for learning, inspiration, and networking, and that's an opportunity that we wouldn't like you to miss. We hold this session twice a week, every Wednesday and Saturday at 9 p.m. GMT +1. So we hope you can join us. For more information about the other initiatives, please visit our website, and we cannot wait for you to join us. Today's agenda is packed with valuable information. We will cover key topics, have an interactive exercise, and we will wrap up with a Q&A session. Now I would like to invite the president of MDS to share a few words with us. Mr. Halim, the floor is yours.
Hi everyone, نتمنى باش تكونوا بخير. كما كنا باغيين نديرو في باغمي بزاف ديال لي زينيسياتيف اللي سميناهم MDS Open Initiatives. كاينه هاد MDS Talks اللي غادي تبقى دار ان شاء الله 2 fois par semaine. Je vous invite tous et toutes إلا تعرفوا des personnes qui sont intéressées باش يبارطاجيو ديك l'expérience ديالهم في data science, data analytics, l'IT en général. Ça peut être du cloud, du cybersécurité, développement informatique appliqué à la data, parce que data c'est pas une spécialité بوحدها مستقلة على data ما عندهاش علاقة بلي autres fields. Donc on vous invite باش تكونتاكتيونا وباش نقدروا نبروغراميو ديك لي لايف اللي غيكونوا ان شاء الله في الباج ديالنا يوتيوب. دونك MDS c'est une initiative اللي دارت صافي دابا 5 mois تقريبا، دارت في ديسمبر 2023. اللي هاد الهاله اللي كاينه على الداتا ساينس قلنا بوكوا با نو با فيغ واحد لا بلاتفورم. دو مون اللي تنهضروا عليهم اللي هو بير تو بير ليرنين، تعلم بالاقران، نتعلموا من بعضياتنا. والثاني هو learning by doing. Quand on parle de learning by doing, on a travaillé sur une initiative qui s'appelle Data Start. On a 2 éditions. L'édition الأولى دارت في janvier 2024. Deuxième édition سميناها Data Store دارت في رمضان. اليوم هو لو dernier délai ديال الناس باش يساليو لي بروجي ديالهم، باسكو واخا تسالى حيت حنا ما بديناش في لو 1 رمضان، بدينا في نص رمضان، دونك عطيناهم واحد 2 سيمين اخرى. دونك كاينين تبارك الله واحد 8 ديال لي بروجي اللي يختاروا واحد لا تيماتيك لي لا داتا ساينس. كما تنعرفوا كاملين ان شي واحد الا بغى يبروفي داك الكومبيتونس ديالو السكيلز ديالو خص ضروري يكون عنده واحد البورتفوليو. وفي كو البورتفوليو موجودين وعطاهم الله في جيت هاب، ما تتبانش لا توش ولا امبرانت انك انت اللي فريمون خدمتي داكشي. دونك on a proposé des thématiques اللي درنا واحد الفورم اللي الناس بروبوزاو دي زيدي. كاين اللي بغى يدير ان شات بوت اللي تيفيريفي لي زانفورماسيون اسلاميك، كاين اللي بغى يخدم على الفلاحه في المغرب يديتيكت لنا مثلا الورق الشجره واش فيهم شي مالادي ولا ما فيهمش. كاين اللي خدام على سنتيمنت اناليسيس ديال لي تويت ولي بوست في فيسبوك في يوتيوب ديال رمضان سور دي فيديو ديال المغرب. كاينين اللي خدامين ال NLP باش الداتا ساينس تولي ابليكي بالدارجه، ونقدروا حتى حنا نصوبوا دي بوت اكسيتيرا ونجمعوا داتا سيت وبزاف لي دوني. دونك كل بروجي كي داير. À part ça, on a beaucoup d'autres initiatives. On a MDS roadmap اللي خدامين عليه ان شاء الله. بغينا نديروا واحد الرود ماب باش الناس اللي جداد في الدومين يتعلموا منين يبداو اكسيتيرا. خدامين على MDS library open library اللي غادي تكون فيها بزاف الكتوبه كيلكو سوا من الانترنت بالانجلي ولا دي ليفر ولا دي سلايد ديال الاساتذه ديال لي يونيفرسيتي اكسيتيرا. بيان سور يبقى لهم الكوبي رايت اكسيتيرا. وخدامين على MDS اوبن داتا اللي كما تعرفوا ملي تنبغيو نخدموا على ان بروجي ديال الداتا ساينس تنلقاو مشكل في الاوبن داتا دونك خدامين عليها اللي نقدروا حنا سوا نسكرابي وسوا نشوفوا لي دوني اللي كاينين ويولي واحد البورتاي اللي دونك خدامين عليه بزاف. ابار سا اون ان جروب سيغ واتساب ديك الساعه نولحوا لكم لو لين ديالو الا بغيتو تدخلوا معنا. سينون vous pouvez تدخلوا لو سيت ويب ديالنا اللي هو morrocands.com راه فيه لي ليان كاملين ديال السوشيال ميديا ديالنا. دونك شكرا بزاف بحيث حضرتوا معنا وحاضرين معنا دابا. غادي نخلي باش ما نطولش بزاف باسكو هذا اول لايف ديال MDS توكس. غنخلي لا بارول لشيماء ولزيد احمد اوان اللي هو واحد سينيور داتا ساينتست فروم باكستان. ثانك يو.
Thank you, Mr. Halim, for your word and for explaining more about the initiatives. For now, we're gonna invite our esteemed speaker, Mr. Zaid Ahmed Awan, a senior data scientist at Royal Cyber Inc., who is gonna speak to us about multi-objective optimization. And please stay engaged during the presentation. Write all your questions in the chat and the comments. We're gonna save them to be answered later, and we are gonna have a quick quiz lined up at the end. Mr. Zaid, thank you for accepting our invitation, and over to you.
Thank you. So, hi everyone. Thank you for joining this session, and I'm really happy to provide this session and hands-on session along with the theoretical session. So, a little bit about my introduction. I have around 5 years of experience in data science, machine learning, data analytics, and data engineering. So throughout my career, I've been working with different ML related project and the deep learning related projects. And from last couple of years, I have been doing the projects related to generative AI and large language models. But in industry, as we know, there are different type of problems. So you can solve those problems by using simple statistical models and mathematical models. You can solve those problems by using any kind of fancy algorithms like deep learning algorithms, neural networks, transformers, and you can also solve those problems by using linear programming. That is a technique for the optimization. So let's say you have different type of objectives which you wanted to achieve, or you have different type of goals, or you perform maybe scenario analysis or sensitivity analysis. So you can do this by using linear programming. But there are some limitations of linear programming as well. So let's say you don't have one objective, you have multiple objectives. Like you want to maximize the revenue, or you want to maximize the profit, but you want to minimize the cost. So these are two different objectives, like conflicting objectives. So in this case, let's say if you have three or two or multiple objectives, in this case, you have some algorithms like genetic algorithms. So you can use those algorithms to achieve your target. But from the lens of data science, how you can use multi-objective optimization along with machine learning, this is the agenda of today's talk. So I'll be explaining the theoretical stuff in first 10 to 15 minutes. Then we'll jump to our practical or hands-on session part. So I hope that you all have access to the Google Colab. So if you have access to the Google Colab, I would love to see all of you installing a library. I'll be sharing the link or the command of the library here, so that you can, just a second. I'm sharing the command. Please install this library. So please open Google Colab and let me share my screen. Please let me know if my screen is visible to all of you. My screen is visible, right? My screen is visible. Am I audible, guys?
Yes, yes, it is.
Okay, so this is the package which is Pymo, and please install this package. Go to Google Colab, start a new notebook, and install this package. You can install this package by simply typing pip install Pymo, but we are using specific version because we have some dependency issues. And please install this particular package. This is 0.5.0 pip install Pymo. So why we need genetic algorithm and what is the purpose of using genetic algorithm, what is multi-objective optimization, this is what I'm going to explain. So let's say I'll start with a problem statement rather than starting with directly starting with my slides. I'll start with a problem statement. So let's say I'm a manufacturing company and I manufacture cement. So let's say I'm using multiple raw materials and I have, different chemical engineer or chemist to do this formulation. And I'm using different raw material, let's say raw material one, raw material two, and raw material three, raw material four. Then there is a column of strength for 2-day strength. Let's say this is, these are industry standards like 2-day strength, and then I have column of 7-day strength. So I hope all of you are very well aware of the regression models, right? So what
I'm
we do
not familiar with it, so yeah, go ahead.
Okay, so what we do in regression models, so we have some independent variables, then we have some dependent variables. So by using independent and dependent variables, we can train a regression model, right? So let's say I have trained three different models. So these are my, let's say uh, these are my independent variables. So these are my like dependent variables. Okay, so I have, four independent variables and then I have three dependent variables. So let's say I have trained three different models. So for example, let me put some dummy values here, like raw material 30, raw material 20, and maybe 50, not 50, 40, 30, 70, and 10. So total 100. And then 40, 10, and 40 and 10, like, and I'm getting, let's say, strength 20, 21 for 2-day, for 3-day 35 and 36, for 28-day, let's say I'm getting 50 and 52. So I am a company. These are my, this is my theoretical model. So there is a difference between theoretical model and surrogate model. So theoretical model, when I say theoretical model, so let's say I am a chemist, I am a chemical engineer. So I have around 10 to 15 years of experience. So I know how to make these formulations. So let's say you are a coffee maker, and from last 10-15 years you are making coffee by adding different ingredients. So these are the ingredients: ingredient 1, ingredient 2, ingredient 3, and ingredient 4. So by adding those ingredients, you know how much quantity of any particular ingredient you'll add to get a particular taste, right? So in same fashion, a chemist or a formulator who's having 10 years of experience, a chemical engineer with 15 years of experience, so from his, from his theoretical point of view, or from his experience, or from his hunch, he can say that by using these particular raw materials, I'll get this particular strength, right, for 2-day, for 7-day, and for 28-day. So this is what we call a theoretical model. So when we have a large number of records or that large amount of data, so we want to follow industry 4.0 trend, and we want to follow the industries which are using AI or machine learning for the formulation. So we want to do the same process. So what we can do, we can train a regression model to predict 2-day strength, 7-day strength, and 28-day strength. But there is problem. So let's say I have trained a regression model by using these independent variables and these dependent variables. I have trained a regression model, and let's say I have trained XGBoost regressor, a tree-based regressor model, and I am getting 97% accuracy. Let's say I'm getting 97% accuracy for 2-day, 95% accuracy for 7-day, and maybe 92% accuracy for 28-day. So this accuracy is good. I can predict the strength of the cement. But the problem is, with each RM, there is a cost. Let's say I have price column. I have price column, and then I have availability column. Let's say availability column, and in price name. So the price of RM1 is, let's say, $3,000, and availability is true, right? So in availability, I have different countries like Turkey and Morocco and Pakistan, India, and UAE. God, UAE. So in availability, true, true, false, 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 and then RM2. So for RM2, the cost is, let's say, $5,000. Availability is false, false, true, 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 right? For RM3, the cost is, let's say, 2,500, and availability is true, 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 false, false. And RM4, the cost is 1,500, and availability is true, 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 right? And then I have some constraints like RM1 can be from one. I can use RM1 from like this is lower bound, and then I have upper bound. So I can use RM1 from 1% to 50% max, and then RM2. Just a second. Sorry, guys. Okay. So, and 5% is lower bound, and let's say 70% is upper bound. 1% is lower bound, 100% is upper bound, and let's say 10% is lower bound and 40% is upper bound. So I have trained a regression model. So by using that regression model, what I can achieve is I can predict the 2-day strength, I can predict the 7-day strength, I can predict the 28-day strength. So these are 3 different models. Then I have some constraints, like I cannot use RM1 above this range. I cannot use more than 50% RM1 and less than 1%. I cannot use RM2 less than 5% and more than 70%. I cannot use RM3 less than 1% and greater than 100%. So I cannot use RM4 less than 10% and greater than 40%, 14%. So these are lower and upper bounds. So these are some constraints. So these are the constraints of proportion constraint. Like I cannot use any particular RM less than the lower bound and greater than the upper bound. Then there are some availability constraint. Like for example, if I am creating a formulation for a particular cement, So the availability of RMs. So RM1 is available in Turkey, but RM2 is not available in Turkey. RM3 is available in Turkey. RM4 is available in Turkey. So these are some availability constraints. Then I have associated prices. So like the RM1. So let's say this price is per metric ton price, or maybe per gram price, right? So per metric ton, the price of RM1 is $3,000, $5,000, 2,500, and 1,500. So this is where multi-objective optimization comes into the picture. So what I can do is I can achieve this by creating or by formulating a problem by using PyMo package. So I have trained a model. I'll use this trained machine learning model as a cost function. So what I'll be doing here is, so let's say this box is my machine learning model, right? So this is my machine learning model. Like this is my regression model, and then I can use this regression model within my optimization box. So within my optimization box, what I'll be doing is that I'll provide the input parameters, like these are the current, like I'm using RM1, the value of RM1 is 50. The value of RM2 is like, 35. So the value of RM3 is 20. So the value of RM4 is, these are my current inputs, like 15. This is my base compressive strength for today. So I am getting 21, but I want to achieve 25. So this is what I want to achieve. So this is just like back propagation. So you have trained a model and you are providing the output that this is the current value which I'm getting by using these RMs. Like I'm using RM150, RM235, RM320, RM415. So I am getting a base compressive strength for today, that is 21, but I wanted to achieve 25. This is for today, and for 7 day I wanted for 7 day my base compressive strength for 7 day is, let's say 40, but I wanted to achieve 45. This is second objective. Then there is third objective, that my base compressive strength for 28 day is 50, but I wanted to achieve 55. So how many objectives right now I'm having? I'm having objective number 1, objective number 2, objective number 3. That's why we call it multi-objective optimization. Then there is fourth objective. And what is that objective? And that objective is, right now by using these RMs, my cost is, let's say $5,000. This is just an example. Let's say my current cost is $5,000. By using these RMs, I want to reduce this cost. So I want to reduce this cost from 5,000 to maybe 4,500. It could be like this. So this is my fourth objective. Or I can say I don't want to, I don't want to exceed the current cost. So the cost should be less than or equal to 5,000. So it could be like this. So this is my fourth objective. So right now I am having four objectives, and then there are some constraints, like any raw material should not, breach the upper or the lower limit of the raw material. So what I'll be doing is, I have trained a regression model. So this regression model is, let's say, 2 day regression model. Then there is another regression model. This regression model is, let's say, 7 day regression model, right? Then I have another model. This regression model is 28-day regression model, right? Then there is a box of cost calculation. This box is of cost calculation, cost, okay. And this box is cost calculation, regression model, and then again regression model. So I have three regression model: 2 day, 7 day, 28 day. Then I have the box of cost. So I'll provide these target strength, these target strength. So here, so what I'll be doing in optimization box. So each time I'll send a random sample to this box, like random sample of RM1, RM2, RM3, and RM4 within those upper and lower bound. So I'll generate a random sample within those upper and lower bound which I have defined, and those upper and lower bound are acting as a constraint. So each time I'll generate a sample, my sample will not breach the upper and lower bound limit of the raw material. So each time in you can say, you can think of it like a for loop. So in each iteration I'll be sending a single sample of rm1, RM2, RM3, and RM4. Like I'm sending maybe 40 for RM1, 30 for RM2. So random sample within those upper and lower bounds. So each time I'll send the sample. So my 2 day model will predict the strength. And then let's say my model predicted the strength 22 for first sample, but my target strength was 25. So 22 minus 25, so it will try to reduce the error, just like we when we train a machine learning model. So in gradient descent or in any sum of squared error, when we use sum of squared error, so what we do is we try to reduce the error. So each time we'll send a sample to each model. Each model will predict the strength. So let's say my model for 2 day predicted the strength 22, but my target strength was 25. So it will find the difference, like the difference is -3. So it will take the absolute, that is 3. So it will try to reduce this distance. So it will try to maximize the strength by reducing this distance. So next time it will generate an other sample, and that sample will try to predict strength more than 22. So maybe next time I'll predict 23, and then I'll compare this 23 with my target strength. Then the difference is 2, right? And in next iteration it will try to improve it, and it will try to send another sample. So let's say my 2 day model predicted 24, and the difference between 24 and 25 is 1. So it will try to maximize the strength by using all these three models. It will try to maximize the strength to achieve these objectives, and it will try to minimize the cost. So let's say I have provided the cost 5,000. That cost should not be, let's say, greater than, should not be greater than 5,000. Should not be greater than 5,000. It should be equal to or less than 5,000. So the cost should be equal to or less than 5,000, right? So it will try to minimize the cost and maximize the strength. So this is the main objective of multi-objective optimization. So if you guys have any question, you can ask, then I'll proceed further with the explanation, and then we'll move to the hands-on part. No question, guys?
So far, no questions. You can
Mhm.
please continue?
Okay, sure. So we'll repeat this process and we'll define a termination criteria, and we'll get a solution like this. So this is my y-axis, this is my x-axis. So this is my y-axis. So let's say for 2 day model, I'll get a solution. This is my complete solution space. Like maybe strength is 20, and so we can take it as negative, then we'll take the absolute. So negative 25, negative 30. So it is like 20, and then 25, 30, 35, and 40. And then the cost is like, you know, cost is 1000, 2000, and 3000 and 4000. And my solution will look something like this. So this is what we call non-dominated sorting, or we call it Pareto front. So what is Pareto front? I'll be explaining in few minutes. So each bubble represents a independent solution, and I'll also having some solution above this space. So these are the dominated solutions. So like these solutions. So all these solutions above this blue line are dominated solution. Dominated by which solution? So this solution is dominated by this solution. 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 So this blue line is called Pareto front. So in this Pareto front, I'll be having multiple solution. Each solution will represent, let's say this solution is saying that by in this solution, I'll be having a single table like this. So this is like RM1. RM1 is 50. RM2 like 20, maybe 20. So RM3, sorry for my drawing. So it is 15. And then RM4. RM4 is, let's say, 10, right? So the cost is, let's say, 700, and maybe 900, and 2000, and 1500. So each bubble is representing this table, a complete solution. That by using this bubble, in this bubble you have these RM values. This bubble is representing a single solution. So in this single solution, by using these raw material, I'll be getting this strength. The strength is, let's say, 23. So by using this red bubble, I'll be getting this strength, which is 23. And what is the cost? The cost is, let's say, 900 total cost. So just an example. So by using this bubble, in this bubble, I have four different RM values. So by using these RM values, I'll be able to get this strength and this cost. So likewise, as you can see, the most optimal solution would be around this elbow point. So it is just like clustering. So in clustering, for example, if you are familiar with k-means clustering. So in k-means clustering, when you have to find the optimal number of clusters, you mostly go with the elbow plot. So in elbow plot, you if you get elbow, like for example something like this. So for example, this is for cluster 1, this is for cluster 2, this is for cluster 3, this is for cluster 4, this is for cluster 5. So this is where we got our elbow. So if I draw a line at this point, I got my elbow index. So what this elbow index represent? This elbow index is saying that the optimal number of clusters you can use is 3. So you can make 3 clusters by using this particular data. So in same fashion, so if I'm getting elbow here, so I can say this is the optimal solution, right? So by using this solution, by using these RM values, I'll be able to get the maximum strength with the minimum cost. So if you are also familiar with, financial modeling or strategic or tactical allocations of assets, or if you are familiar with the investment banking, so you have a portfolio, you have invested in real estate, you have invested in, maybe in healthcare, in real estate, or maybe in retail, maybe in supply chain, maybe in gold, maybe in crypto. So you have a very diverse portfolio. So let's say if you have a very diverse portfolio, so there is something what we call is Markowitz efficient frontier, which looks something like this. So in Markowitz efficient frontier, what we can say is this is the risk associated with this portfolio, and this is the return associated with the portfolio. So this is the point where you get, where you can get the minimum risk. This is the, let's say, risk, and this is the, return. And this is the point where you can get the maximum return. So this is Markowitz efficient frontier, can be used to get the optimal index of the portfolio. By using that optimal index, I can get the maximum return and the minimum, risk associated with the return, with the portfolio. So guys, we'll be starting hands-on session in next 5 minutes. So before starting the session, I'll quickly explain, the multi-objective optimization from the theory of natural selection point of view. So basically, it's a biological theory of natural selection. So for example, let's say you want to maximize something, you want to maximize two objectives, and you want to minimize one objective. So you can use these genetic algorithms. So we'll be using these genetic algorithms, but how genetic algorithms are associated with this, with this, mathematical problem. So in genetic algorithm, we have some generations. So over the period of, let's say, a few hundred years or few thousand years, so these generations, those generations mutate, and those generations crossover, make some crossover, and those generations also mutate. So the survival of the fittest, it is just like the survival of the fittest. So for example, if a generation is the best fit, or if the generation is the fittest from the previous generation or from any other generation, so there are, maximum chances of the survival of that particular generation. So that particular generation can mutate, or that particular generation can, make some crossovers to generate more generations, more fit generations. So that's why we use this same technique in genetic algorithms. So so in each iteration we send samples. So for example, if some samples are not able to, perform well, or not able to generate, or predict the maximum strength, which is a desired strength for each particular day, then I'll be discarding those generations, I'll be discarding those samples, and I'll not let those generations or those samples to do mutation or to do crossover further. So that's why I'll be discarding those poor generations. I'll just keep the best fit generations or the fittest generation to further mutate and to further make some crossovers. So that's why we call it, multi-objective optimization using genetic algorithms. Any question till now? So I'll be moving to, our hands-on session. So this is all about theory. I'll be sharing these slides with you. You can have a look. So we'll be solving this problem in this hands-on demo. So we are having two objective functions. So this is an algebraic function. So you can, so let's say you don't, you only have the data, and you don't know the equation of the data, you don't know the algebraic equation of the data. So what you can do is you can simply train a machine learning model to get the equation. Like I was explaining the regression part. So what is regression? Regression is y is equal to mx plus c, right? Mx plus c. So this is simple linear regression. Just a second. This is simple linear regression, right? So what is y? Let me So let's say this is my y-axis, this is my
Sorry, Zaid,
x-axis.
Zaid,
Yeah,
can
yeah.
you please like use the uploaded slide so it's gonna be more convenient for us to not wait like the slide uploading?
Sorry.
Can you use the uploaded slides, the pre-uploaded
So,
slide?
okay, just a second. These slides.
Yeah, you can use them.
Yeah.
They already
So
uploaded because when you share the screen, like we wait for the slides to upload, and maybe network, so it takes a little bit of time.
mhm, mhm. Just so I have uploaded these slides already. Just a second. So guys, are you boring, or you are able to understand what I'm trying to teach?
We are on board. We are focusing with you. Inshallah, hopefully, we're gonna understand. Thank you, Zaid.
Inshallah. So slides are visible. So I have uploaded the slides. Here are the slides.
Okay, they're
Yes.
visible now. Yeah.
Yes.
Sorry,
Okay.
Zaid. Go ahead. Continue, please.
Yeah. So this is the problem which we are going to solve. So in this problem, we have two objective functions. Like the first objective function is x1 square plus x2 square plus x3 square. That's the objective number one. And then I have to minimize this. And then I have another objective, that is negative of x1 minus 1 square, negative of x2 minus 4 square, negative of x3 minus 3 square. So this is the second algebraic equations. So right now I am having two different equations. The first one is I have to minimize the first function, and then I have to maximize the second function. So function is nothing but my objective function which I wanted to achieve. So this is what I was trying to explain in my paints, that in regression you have equation like y is equal to mx plus c. So if you're not having any theoretical model, like you will not be able to get these type of equations from the client. So client will not provide you, client will simply provide you data. Client will say, hey, this is my data, this is what I was trying to do from last couple of years, this is my data, like these are the values of the raw material, and this is the strength which I was getting. Take this data, create the equations, and then perform this multi-objective optimization, and then give me a model where I'll just provide the input values, like these are the current composition values, these are the current raw material values which I am using to get this strength. But I want to improve the strength, and in parallel I want to retain the current cost, or I want to minimize the cost as well. So the maximization of the strength and minimization of the cost. So maximization of three type of strengths, let's say strength for 2 days, strength for 7 days, strength for 28 days, and then I want to minimize the cost in parallel. So these are four objectives, but right now on the screen you can see we have two objectives. One objective is there is a function x1 square plus x2 square plus x3 square. I have to minimize this function, and then there is another function that is negative of x1 minus 1 x1 minus 1 square, x2 minus 4 square, x3 minus 3 square. So I have to maximize this function. But the problem is client will never provide me these equations. I have to extract these equations. So how can I extract these equations? So you can use machine learning. So this is where machine learning comes into the picture. You can use you can take the data, then you can train a machine learning model. So that machine learning model will provide you, let's say you are using regression, simple regression. Let's say you're using simple regression. So that machine learning model will provide you equations for each day. Then I can use those equations to maximize or minimize, right? So coming back to the problem statement, we have two functions. Let's say I have applied a machine learning model just for the understanding purpose. This is not the equation which is generated by machine learning model. This is the equation which is generated by a theoretical model. So in complex scenarios, the scenario which I was explaining related to manufacturing industry, you can, generate these equations by using machine learning model. So let's say I have two equations. One equation I have to minimize, that is objective number one. And then there is another objective that I have to maximize. So one objective is to minimize and the second objective is to maximize. Then I have two constraints. So these objectives are having some constraints like x1 plus x2 minus x3 should be less than equal to 1. And then there is another constraint that 3x1 minus x square minus x3 should be greater than equal to 4, right? So you can rewrite this constraint like this. So you can simply, rearrange these values, and by rearranging, you can, convert this greater than equal to into less than equal. So why I have to convert this greater than equal to into less than equal to sign? Because if we are using PyMo package, in PyMo package we are having two type of constraint. A, we are having equality constraint. B, we are having inequality constraint. So right now we are having inequality constraint because in both objectives we have less than equal to or greater than equal to. So we'll be using inequality constraint. So in PyMo package we cannot use greater than equal to. So PyMo is not able to understand this greater than equal to sign. So that's why we have to rearrange these values, and we converted this greater than equal to sign into less than equal to sign. But these both of these equations are exactly same equations. Then we have some bounds. So we have two objective functions: minimize this function, maximize this function. Then we have two constraints, two objective functions, f1, f2, g1, g2, two constraints. Then we have bounds of each variable like x1 can x1, the lower bound of x1 is minus 10 and the upper bound of x1 is 10. So any value which I'll be using for this x1 should be greater than negative 10 and should be less than 10. And for each x, like for this x2, if I'm using any value, that value should be greater than negative 10, less than 10, greater than negative 10, less than 10. So these are the upper and lower bounds. So this is the problem statement. If you have any question related to problem statement, you can ask. Otherwise we'll move to the Jupyter notebook.
No question until now. Please continue.
So guys, please install this package. So we'll be, let me share this notebook here. Can I share this notebook? Just a second.
Can you share with us the link?
Link. Just a second.
Yeah.
Link of Jupyter notebook, right?
Yeah, exactly. Yeah.
So I have also invalid file type. Just a second. Just a second. share. Okay. Hmm. Access. I think I have to provide the access. Guys, please open this link and let me know if you are able to open the link. Otherwise, I'll provide the access.
No, not yet, not yet. You should give us the access.
Mm-hmm.
The access
Share.
to see it or edit it.
Mm-hmm. So restricted, anyone with the link, right? And
It's,
editor.
it's top right of the screen of the collab.
Mm-hmm. Just a second. So please go to this link and you will be able to access this.
Yeah. No, 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 no.
Yes,
It's
are
not.
you able to
Yeah,
access this?
no,
Let
it's
me
not collab link. It's a
let
Jupyter.
me show
Mhm.
something, please.
Yeah, please share your screen.
Okay.
Mhm.
So here when we click on the link, all right. So I click on the link. We can have this. It's a file. Okay. We can download it or open it with directly with the Google Collaboratory.
Mhm.
So when we click here, we can see it's that's it. Continue, please.
Okay, sharing my screen. So guys, please don't install Pymo. Always install Pymo 0.5.0. So install this package. So connecting with the runtime, just a second. It will take some time and then it will install the package.
Um,
So install.
Zaid,
So are you, yes.
again, but we cannot see the screen, so can you
So
share your
you
screen?
cannot see the screen. Okay, sharing the screen, entire
Thank you
screen
so much.
window. No issue. Okay. So my screen is visible.
Yes.
Yes, it is now.
Mhm. Yes. Guys, please install Pymo 0.5.0, not Pymo. If you will install pip install Pymo, some of the packages will not work. This Pymo core problem will not work because it's depreciated. So please install Pymo 0.5.0. Let me know when you are done.
It's exactly that. We tried some collab about this PyMo with the
Mhm.
latest version, and we found some problem. So
Yeah,
yeah,
yeah. So because some
yeah.
of the packages are depreciated. Guys, please let me know when you are done with this installation part.
Guys, please write in the chat if you are done in the comments.
I'm sharing this command again. Please install this package.
Guys, we're waiting for you in the chat to write done. Okay, Kautar is done.
It will take, I think, probably 1 minute max.
Mhm.
So
I
take
see
it
two.
easy, guys. No hurry. Just try to install this package and let
It's
me know.
take,
if you are-
it takes 1 minute. Yeah, it's so fast because we use the collab.
Mhm.
The internet is so fast.
Mhm. So if you are done with this installation, then you have to import these two packages. NumPy as NP. So we use this package for mathematical manipulation. Like if you want to play around with numbers or you want to multiply something, number crunching, data manipulation, or you want to play around with arrays. So you can use this NumPy package. And then from pymo.core.problem, you have to import this element wise problem. So if you are not using this version of pymo, you will not be able to import any of the thing from this core package. So that's why we installed that particular package. So once we are done with this import part, so we have imported these two package, this for data manipulation, and this element wise problem is for the multi-objective optimization. So we have to define, actually will inherit this class. So you are hopefully you are familiar with, OOPS or class inheritance. So we'll create a class like my problem. So you can customize this. You can create your own class like cement strength optimization, like coffee taste optimization, anything, right? So you can create your own class. Then you have to simply inherit this class. So once you are done with this, then there is a constructor. So in this constructor, this is very important, guys. In this constructor, I'm using super. So in this super method, so for the constructor of this class, I'm defining variables. So in my problem, so the problem which I was showing, that in this problem, how many variables I'm having? Three variables, x1, x2, and x3. How many objectives I'm having? Two objectives. How many constraint I am having? Two constraint. And these constraints are not equality constraints, but inequality constraints. So again, guys, we are having like two objective function. So we have to minimize one, we have to maximize one. Then we have two constraints, two inequality constraints, and then we have three different variables with upper and lower bound. So coming back to the code part, how many variables? N underscore variables, three variables, x1, x2, x3. You can have 50 variables, you can have 40 variables, 50, 60, 70, any number of variables. It depends on your problem, like how many variables you are using. So for example, you have trained a machine learning model, and to predict something, you have to provide 10 different values. So how many number of variables you have to use here then? 10 variables, right? But for this problem, I'm using three variables. And number of objective is nothing but number of functions. Like one function, one objective, which I have to minimize, and the second one, which I have to maximize. So three variables, two objectives, then two inequality constraints, right? Two inequality constraints. Then I'm using numpy array here to define the lower bound x lower and x upper. So x lower is the lower bound of all these three variables. X upper is the upper bound of all these three variables. So the lower bound is negative 10 for all these three variables. The upper bound is positive 10 for all these variables. So this is it for this super method. Then there is another method which is very, very important to define your problem, that is underscore evaluate. So in underscore evaluate, you'll pass this x. This x will contain, so this x will be a standard x. So you have to write x here, right? You have to write out here. You have to write static arguments, static key variables. So you have to write all these things as it is. So I'll explain one by one. So this x is nothing but, this x is what we will this x is the sample which will be sending to this genetic algorithm. Like I'm generating a random sample. So like x value of x1, value of x2, and value of x3. So I'm generating random samples, and I am sending those samples to my genetic algorithms. So this is the x, and in this out, uh, actually this is a variable where I'll be storing my output, right? So I'm using this out here. So this is this out f is storing my two objective function, this out g is storing my two constraint. So starting from this line, you'll use this line as it is. Just a second, guys, let me, yes. So you'll starting from this line, you'll use this line as it is. Then you have to write the equations. So you can use, instead of using this equation, you can also use your machine learning model here. Like model, how you will be using machine learning model? You can use like, just let me write another line, like f1. F1 is model dot predict, and in model dot predict you will provide some input value. This will predict, let's say this will predict the strength of cement, right? Model predicted this strength. Then the f1 is that, and then you have the target strength, like target, this is a hard coded value, like I want to achieve 25 for today. And then f1 will become target strength, which you wanted to achieve, minus predicted strength. So let's say this is predicted strength. So it will become something like this. So for example, if you are not having this equation, you can use your model. This is regression model. It will take the x. By taking the x as an input, it will provide the strength. Let's say this model is trained to predict the strength for 2 days, 7 days, or 28 days. This model will predict the strength. Then I have my target strength. Then the objective function, the first objective function will become like something like this, that target strength minus predicted strength. So it will subtract the predicted strength from the target strength. So it will automatically try to minimize the distance between the target strength and the predicted strength. So right now we are not using any machine learning model. So we are using this equation. So this is my first objective function, like x1 x0 square plus x1 square plus x2 square plus x3 square. So this is my first objective function, and this is my second objective function, right? So I have just written the equation like x1 minus 1 square plus x2 minus 1 square plus x3 minus 1 square. So these are my two objective functions. Then these are my two constraints, right? So these are my two constraints. So you can convert this less than equal to or greater than equal to into a equal sign by just shifting this -1 to the right side, this one to the right side, and this 4 to the right side, right? So these are two constraints, and then I can store these two objective functions and these two constraints in these out files, right? So this is how we can define our problem. So run this cell. So if you are done with this and you are not getting any error, please let me know.
No error
I
from
take.
my side. I'm gonna wait for the comments to tell me. Please, guys.
Mhm.
Can you tell
And
me
if
the
you have any question, you can ask at the end of this session.
Yes,
Don't
of
worry.
course. We told
I
them that
mean,
we're gonna
this
save the
is this.
questions for later.
Yeah, please go ahead.
Yeah, I said we told them that we're gonna save the questions for later so you can answer them.
Yes. So these are some these are these topics are little bit advanced, but not very hard to learn.
I
If
am
you
sure.
spend some time, yeah, if you spend some time, and if you try to you can also use chat gpt or gemini to learn the concept or the underneath intricacies behind these algorithms, and just try to use these algorithms in your own problem. And
Mhm.
after 5 6 days or maybe few days, you'll be able to understand each and every nitty gritty related to this
Mm.
algorithm. So
Amazing.
we have defined two objective functions, then we have also defined two constraints, and then we are using this out variable to store our objective function and our constraint. So we have defined our problem. Then we have to, after defining the problem, we have to use any particular algorithm to solve this problem. So for this particular problem, we are using NSGA2, which is non-sorted genetic algorithm, right? So two means for two objectives. So mainly this algorithm is used to solve multi-objective optimization having two objectives. So you can use this NSGA2 or NSGA3 by solving like problems having 3, 4, 5, 6, 7 objectives. Then you have to use this sampling, float sampling technique. So why float sampling? So what is the purpose of using float sampling? Why I am not using integer sampling or real number sampling? Why I am not using my historical data to generate sampling? Yes, you can use. So let's say you want to use integer sampling, but you don't want to use any float number in your sample. You can go with the integer sampling. But let's say you want to use your own historical data to instantiate the initial sampling. So you can also use your historical data, which you have used to train the model to generate samples, right? Then from operators, you have to import crossover and mutation. So crossover is, I mean, nothing but, let's say, let's say this is sample one. In sample one, I generated X, which is, let's say, -5, and X1. X2 is maybe -3, and X3 is 6. This is sample 1. Then this is sample 2. In sample 2, I have, 4, 5, and 4, 5, and 9, right? And in crossover, what we'll be doing is we'll simply, like crossover 1 and then crossover 2. So we'll simply swapping these values, like crossover is, let's say, sample 1 and sample, sorry, sample 2. So for sample 1, let's say we'll just swap these values. So the first sample will become 4 -3 9, and second sample will come -5 5 and 6. So this is crossover. And in mutation, what we do is, so let's say this is a final sample. Let's say we have generated a final sample and the values of the sample is 4, 7, and 2. So this is the final sample. So final sample mutation. So this mutation is just like the mutation of coronavirus. So coronavirus, the 90% or the 80% properties will remain same. Some of the properties will get changed. Like, so it will come 4 or maybe 2, 7, 2. So this is what we call mutation. So you can also use some variables to control this mutation. So for example, there is a variable called eta. So if I'm using bigger value for the eta, like 50 for the eta, so it will try to penalize this mutation. So it will not let this 4 to mutate maximum, like the 4 can mutate up till 3 to 5. Like it can be 3 or it can be 5, but not less than 3 and not greater than 5. Or maybe you can control it like this, like the 4 should not go greater than 4.5 or less than 3.5. So something like that. So by using this hyperparameter, you can control the mutation and crossover part as well. So we are using the inbuilt function for the mutation and the for crossover and for mutation. But the problem which I was, explaining initially related to the strength of the cement. So we have created our own functions of mutation and crossover. So you can create your custom crossover functions and custom mutation functions, and you can use your historical data for the sampling. But for this problem, we'll be using the random sampling, float sampling. Will be using inbuilt crossover function, and will be using inbuilt mutation function. So we have imported NSGA2 pymo.algorithms dot m double o multi-objective dot nsga2 import nsga2. Then we have imported this package, this package, this package. So run this cell. Then we have to instantiate the NSGA2. So we have instantiated NSGA2. You can set the population size. This is a hyperparameter. You can set it 50. You can set it like, so let me set it, you know, maybe 500. And then you can also set the number of offsprings, like maximum 10 or 20 or 30. Then for sampling, you have to instantiate the sampling which you imported. Then for crossover, you have to instantiate the crossover, SBX crossover, and you have to set the eta value. The larger the eta value, the less the crossover. The smaller the eta value, the smaller the crossover rate is. Then you have to also instantiate the mutation. So this PM is mutation. So the larger the eta value, the less the mutation. The smaller the eta value, the larger the mutation. Then you can eliminate the duplicate true. So if you set this value to the true, it means it will eliminate all the all the same or duplicate solutions, right? Then you can, run this command from pymo.termination import get termination. And I have imported this package. And then you can set this to the number of generations, like terminate my solution if it is not improving after 100 generations. So you can run this command. So it is saying module not found. Just a second. So guys, if you are getting error here, please let me know.
Yes, I got the error. I don't know what does it mean.
Just a
Waiting.
second. So
Guys.
you can use this command.
Mm-hmm.
I am sending the command. Just a second. Guys, please use this command. From pymo.factory import. So please use this command if you are getting error. So you can ignore this get sampling command, or you can use this one. So pymo.factory import get termination, and then just copy this line. And so let me comment it out. And this is the complete line which you have to use. Again, sharing here. Okay. So you can copy this line. Okay. So you'll be able to run this. Okay, perfect. So it's working. So you imported the get termination from factory, and then you set the number of generations, like after 100 generations, terminate this code, right? And then from pymo.optimize import minimize. So minimize is a method which you have to import, and then by using this minimize, so what is this problem? This problem is nothing but, just a second, I have to delete this. So this problem is nothing but just this problem is this class which I have created, my problem class. Then I have instantiated my problem, and I have stored this my problem as an object in this variable problem, right? So then I'll provide in minimize, I'll provide problem, then I'll provide algorithm. So from where I can get this algorithm? This algorithm is nothing but this method. So you have imported NSGA2, and then you have instantiated NSGA2 and stored it in a variable algorithm, right? So you have provided the problem, you have provided the algorithm, then you have to provide the termination criteria. So this termination criteria is nothing but this import package. So you have imported a package get termination, and then you have set this as number of generations 100, right? Then seed value is a hyperparameter, then save history true, verbose true. So if you set verbose to true, you can see this, while running this, you can see this output. So because I'm using 500, my population size is 500, that's why it took some time. Otherwise, if your population size is less, it will quickly run this solution, right? Then from where you can, so all your solutions are stored in this variable res variable. So in res variable, you have two different variables, res.x and res.f. In res.x, you will have all the values, like the value of x1, x2, x3 for each solution. And in res.f, you will have two values. One is for objective number one and second is for objective number two. So let's say I have I run this command, I run this cell, both of the cells. So in X, I have all the X1, X2, X3. In F, I have the objective function. So let's say one objective function which I have to minimize is, so this objective function is, let's say, cost. This objective function is strength, right? So this is the cost, this is the strength. If you print this, right? So I got only three values. Let me reduce the number of, so population size was 20. So no, it started penalizing the code, right? So I got these values, these. So this is, let's say this is the cost. So F1 is cost and this is the strength. Just an example, right? So this is the cost, this is the strength. And then for this solution, let's say if someone asks you that give me first solution and the value is related to the first solution. So F0, just a second. So this is your first solution. Like this is the, you can slice and, you can slice it and you can get both values like this. So this is your first solution. So for this solution, what is your, x1, x2 and x3? So this is my x1, this is my x2 and this is my x3. By using these x values, this is the cost which I'm getting and this is the strength which I'm getting. I'm just telling you a story, like this is just an example. So actually this is not cost and this is not strength, because we have to minimize this function. So that's why I'm just saying that this is the cost and this is the strength. So you can visualize this solution like you have two objective functions, right? So uh, this is cost, let's say, and this is strength. You have two objective functions and you have multiple solutions, right? So if you want to minimize this, you can use this pymo.visualize.scatter plot, and in scatter plot you can provide the title, and then in plot.add you can provide your objective function f with x value and y value, provide the color, and plt dot show or plot dot show. Then you can get, this is the Pareto front, right? So each solution having, two values like x-axis and y-axis. So for this solution, we got very high value of the objective 2, but we got very less value of the objective 1. So that's why we call this type of, problem, uh, you know conflicting objectives problem. So we have two objectives, two conflicting objective. If I am increasing, like let's say if I'm increasing one, I have to decrease the other. If I'm, let's say, decreasing one, I have to increase the other. So that's why for this solution, I'm getting, let's say, 3 for second objective function, but I'm getting value near to 0 for first objective function. So this is your Pareto front, right? And if you want to get the optimal solution, So you have to get the ideal point and nether point. So what are the ideal points and nether points? So basically, the minimum values are your ideal point. So in this complete solution space, the minimum values are your ideal points and the maximum values are your nether points. So you can run this cell, you'll get the ideal point, then you will get the nether point. These are the minimum values for two objectives. These are the maximum values for two objectives. This is nothing but just to plot. So I have plotted the ideal point and provided the marker as star. Then I have plotted the nether point and provided the marker as pentagon, right? So you can say this is the pentagon and here we have the star. So in this complete solution space, this is my, nether point and this is my ideal point. But this is the solution, non-dominated, non-dominated optimal solution, Pareto front. So what we can do is there is a technique which we call is compromise programming. So in compromise programming, so I cannot use all those solutions. I have to select one single solution. The way we select optimal uh, number of clusters by using elbow method. So we select one solution where we got the elbow index. So let's say we got the elbow index at index number 3. So the elbow index is, let's say, index number 3. So we'll be using that particular index to retrain our unsupervised clustering k-mean clustering model, right? So in similar fashion we can also extract the one optimal solution. So to extract the one optimal solution from all these, so these are all feasible solutions, ideal solutions. So to select a one optimal solution from all these feasible solutions, we have to do compromise programming. So what is compromise programming? Quick overview. So this is the Pareto front which we got. These are all dominated solution. These green solutions are all dominated solution, but these red solutions are non-dominated solution. So what is meant by non-dominated solution? You cannot get any better solution other than this solution. So this is what we can say. This is why we call them non-dominated solution, because we cannot improve these solutions further. So these greens are dominated and red ones are non-dominated. And then we have you know multi-criteria decision making. So for multi-criteria decision making, we use compromise programming, pseudo weights, and analytic hierarchy process technique for order preferences, goal programming, elimination, and choice translation. So in compromise programming or pseudo weight, what we do is, normally, if we follow any other technique like linear programming, we assign weights to both objective function. We convert two objective function into a single objective function, and that type of problem are called scalar problem. But we have a vector problem in which we got multiple solutions. So we'll convert this vector problem to a scalar problem by using compromise programming. So in compromise programming, we have to assign some weights to our objective function, right? So you can study this slide and you can get back to me if you are not able to understand, but we are running out of time. That's why I want to cover quickly this notebook. So we normalize the values, like we convert the values, all the values like we have from 0 to 3 x-axis, 0 to 3 on y-axis. So we'll convert it into a normalized scale like 0 to 1. So after converting these values, so sorry, just let me find the normalized function. And so we got the nether point, ideal point. So we normalized all the values from 0 to 1. So f1, now the scale of f1 is 0 to 1, scale of f2 is 0 to 1. So then if you plot the normalized value, you will get the same plot, but you will have different scale on x-axis and on y-axis. Then you can use compromise programming. In compromise programming, you can assign weights to your objective function. So let's say I'm saying cost is not an issue for me. So if I can spend more dollars, right, to create a composition, but strength is very important for me. I want to achieve the strength. or other way around, you can say strength is not important for me. If I'm getting little bit less strength, it will work, but cost is important for me. So it depends. So for example, you can assign weights. So you have to import from pymo.decomposition, you have to import augmented scalar function. So you have to instantiate this function. So after instantiating this function, you have to create an array of weights. So in array of weights, you assign the weights like 20%. The importance of objective function 1 is 20%. The importance of objective function 2 is 80%. So you have to assign the weights. Then in this decomp dot do method, you have to give your normalized objective function values, and then you have to give the reciprocal of sorry, inverted value of your weights, 1 divided by weights, and then you have to find the arc minimum of this function, right? You run this cell, you'll get the optimal index. Then I'll run this cell. After running this cell, it is saying that this index number 14 is optimal index. Then I'll plot it, right? So this is the optimal solution. So I can use this solution, that this is the best solution for the cost and the strength, desired strength based on these weights. So you can change the weight, like I can provide 70% to this and 30% to this, right? Then I can run this cell and run this cell, and then I can run. So then the solution changed. See? So now it is saying this is the best optimal solution. So this is it, guys. The next slides are pseudo weight is another technique. You can try it. And then this is also, by assigning weights, you can perform pseudo weights as well. This is a simpler technique. Compromise programming is a little bit complex, but this is it. If you'll have any question, you can get back to me. Thank you. So I'll take questions in next 5 minutes. You can ask questions, then we can close the session.
Guys, if you have any question, please write them in the comments.
Please try this notebook in your try this notebook in your own problems. Like
Mm-hmm.
for example, let's say you can try this problem in inventory optimization. So how can you try this problem in inventory optimization? You can, for example, let's say you have an inventory network. Just last 5 minutes, and let me share my screen again. So you can, replicate this problem. So let's say I'm wrapping it up, guys, in next 2 to 3 minutes. So please focus. So let's say you have one warehouse, and from this warehouse you have shop one, shop two, and shop three. You want to avoid understocking, you want to avoid overstocking. You have a demand forecasting model, and you
Zaid,
have,
I think we're not seeing your screen, so you can share it, please.
yeah, just a second, I'm sharing again. Mm, type screen.
Yes.
Let me know if it's visible.
Let me see. Not yet, but I'm sure it's gonna be visible after a few seconds. Yes, it is visible now. Thank you.
Okay. So let's say you have three shops, shop one, shop two, and shop three. And this is your production house, maybe, or maybe warehouse, or maybe DC, right? And you have implemented a time series based demand forecasting model, right? And you have forecasted the demand for month one, month two, and month three. So let's say for month one, for a particular SKU, let's say I'm talking about a SKU one, stock keeping unit. SKU means stock keeping unit. So I am talking about SKU one, which is nothing but, let's say maybe coffee, ice cream, something like that, or maybe a cake. So let's say for month one, the forecast is 50. So for January it's 50. For Feb it's forecast is, let's say, 30, and for January, sorry, Jan 50, Feb 30, and March it's 70. But you don't have enough stock, right? So let's say at shop 1 you have maybe 10 units, at shop 2 you have 5 units, at shop 3 you have 7 units. So you have to optimize this inventory by using this genetic algorithm. So think about it. How can you solve this problem? So you can move the inventory from this warehouse to these shops. So from this warehouse, if I'm moving inventory from this warehouse to this shop, the cost is $10. Let's say from this warehouse to this shop, the cost is $20. That is logistics cost. From this warehouse to this shop, the cost is $30. I can even interstore transfer. I can do interstore transfer. I can move things from this shop to this shop. So let's say I am having 100 units at this store, right? So the inventory is excessive inventory. I can move this inventory from shop 3 to shop 2. So the cost is, let's say, $5. So instead of moving anything from warehouse to this store, instead of moving from warehouse to this store, I can move inventory from this store to this store, right? The excessive inventory. This is where your inventory, you can create an inventory balancer. You can, optimize your inventory. You can optimize your supply chain by using these genetic algorithms. So what you have to do is you will have two objective function. One objective function is maximize the number of transfers, right? And the second objective function is minimize the cost. So these are the two objective functions. So minimize the cost and maximize the transfers. So this is where you can use this genetic algorithm. So you have trained a machine learning model, a time series based model for demand forecasting. After you are Once you are done with your demand forecasting, you have to balance out your inventory. You have to make some inventory interstore transfer or warehouse transfers. So then on top of that, on top of your demand forecasting algorithm, you can use these genetic algorithms to optimize this network, right? So think about it, and if you will not be able to solve this, please let me know. I'll help you solve this problem. Thank you.
Thank you, Zaid. I see some comments in the chat before passing to them. I also have a question about the pseudo weights. How
Mhm.
do we choose them? Because I noticed that you chose like 0.2 and 0.8. Like, do we have a
Mhm.
method or like it's like related to the experts? Um,
Yeah, 0.5 or 0.8, what the package? Pimo package?
it's like by standard in the final package.
No, it's not like standard. So, for example, let's say if you are getting some error in the latest version, so you can simply, try the previous version. So, let me quickly show the last thing. So, go to this site, pypi.org, right? Write any package name like Pimo. My screen is visible, right? My screen is visible.
Yes, it is, yeah.
Yes, yes.
Okay, so then you can go to this release history. So the latest package is 0.6.1.1, released November 26, 2023. So you can simply, install the previous versions. So previous versions are more stable. Yeah. So I have just, what I've done is, so when I was using this package, I was getting the same error. So I just tried 0.6.1, or you can search. So for example, if you are using OpenAI, so sometimes you face error like chat completion is not available, right? So you have to install the previous version of OpenAI. So in same fashion, you can simply try like 0.6.1. If it is not working, you can try 0.6.0, 0.5.0, or otherwise you can Google it. So there is no, I mean, hard coded formula for this, you know, to get which package, which particular version will, or which particular release will work for me. So you have to, I mean, find it one by one, or you can Google it, or you can use Stack Overflow, or you can use ChatGPT, Gemini.
Cool. Kautar, can you open your mic or do you want me to read the questions for you, please?
Can we use the Pareto method combined with machine learning? For example, if I have a data set containing many machine names and the problem causing them to need repair. This is something else. This is related to predictive maintenance. We'll be cover this in our next session, where you can use causal inference here, but Pareto method is something else. So Pareto method is used to see the impact of conflicting objectives, like for example cost and strength or something like that. But in predictive maintenance, I don't think so that you can combine Pareto method for predictive maintenance or for causal inference. I want to predict which machine, sorry, I want to predict which machine will need repair while also applying the Pareto principle. Fix only. So yeah, I got it. So that Pareto analysis is something different. That is 80-20 rule. So we also call 80-20 rule Pareto analysis. So like 80% of the data is not very important, but 20% of the machines or 20% of the data is important. I mean, 20% of the data or 20% of the machines are doing your 80% of the work. That is different Pareto analysis or Pareto principle. So this Pareto front is different. However, I'm unsure if this is feasible. Do I need to apply the Pareto principle to then feed the input? No, no, no. That Pareto principle can be used in your causal inference and EDA part. That is different Pareto principle. That is 80-20 rule. This Pareto front is different. This is Pareto front, not Pareto principle. So we'll be covering this type of things in our next session of predictive maintenance session. So we'll be using sensors data. So then we'll using Kafka, and we'll predict the anomaly in the pumps, and there I'll be explaining how you can uh, schedule or reschedule or distribute the orders of machine if you get the anomaly, such as creating only graph to visualize the problem causing maintenance need for. Yes, you can use this Pareto. Yes, you're right. So you can use this Pareto principle just to visualize like which machines are important or which is the important sensor causing this issue. How can the integration of multi technique improve decision-making process in complex engineering projects compared to the traditional single? Yeah, that's a very good question. So in traditional single objective optimization methods, we normally use linear programming. So in linear programming, we try to convert multiple objectives into a one single objective. That's why we call them scalar problems. But in genetic algorithms, we can get multiple solutions. So that's why we call it a Pareto front, where we can get like 50, 40, 30, 25, 60 different solutions. And then on top of that, you can perform goal programming or multi-criteria decision making or pseudo weights to select one single solution. So it can be applied across different industries and in different problems. Like I have used this same solution for manufacturing industry. One of the company, which is Fortune 500 company, they are making additives. They create additives for to improve the cement strength, but they were using from last 10 to 20 years. They were using theoretical model, and we just converted this problem from theory to a surrogate model, and we created an AI model, and they are very happy with it. Thanks, guys. I think it's quiz time. Over to you.
Thank you, Mr. Zaid, for the enlightened presentation. It was, as you said, a little bit advanced. At least for me, I had to focus a lot. But we really grateful because we know that timing is very inconvenient. It's very late out there in your country. So
No issue.
we just
No
want
issue.
to
Most
appreciate
welcome.
your time. Thank you so much.
No issue, no issue. Most welcome. Thank you. So I'm leaving, guys. You can, take the quiz.
Thank you so much, Zaid,
Yeah.
again.
Allah.
Guys,
Yes, thank you, Zaid. Another time, thank you.
No problem. No problem,
Yeah.
guys. Most welcome. Allah Hafiz.
now we're gonna start the quiz. Please scan the code or just enter, click on the link. Did you guys scan the code? I'm waiting for the players to come along. So yeah, I'm seeing the comments. Okay, let's go. First question.
شيماء, can you share the screen to باش نشوفوا الريزلتس؟
I did. Is not visible for you guys?
No.
Okay, let me check. Now?
It's visible, yes.
Okay, cool. Let's start. First question. I hopefully you answered the first question.
No.
You didn't, guys. I guess it's too late. Let's go back and see. Okay, first question. Second question, I guess. Is the screen visible for you guys? Please answer the question. It is now visible. Okay, we got 2 for 2. 2 people got it wrong and 2 people got it right. Next question. The correct answer is involve trade-offs between conflicting objectives. Third question, we're gonna pass to it now. Okay, the third question is, in multi-objective optimization, what is the Pareto front? Pareto front. We have 4 choices: region where all objectives are maximized, set where no objectives are optimized, set of non-dominated solution for trade-offs, applicable only to single objective problems. Yay, we got it. 2 people got it right and 1 only who got it wrong. So the correct answer is set of non-dominated solution for trade-offs. I'm gonna pass to the fourth question. Which algorithm is commonly used for solving multi-objective optimization problem? I guess this one is easy. First, we have breadth first search, depth first search, genetic algorithm, Jigsaw algorithm. Oh, this one got it right. Yes, it's genetic algorithm. The fifth question is, what is the purpose of scalarization in multi-objective optimization? Converting multi-objective problem to a single objective, adding more objectives to the problem, minimizing the number of objectives, prioritizing objectives by importance. Think well. Mr. Zaid just spoke about it like 10 minutes ago or like 5 minutes ago. Scalarization. And the correct answer is converting multi-objective problems to a single objective. This is the correct answer. So yeah, with that, we've finished our quiz. This is only to help you to foster the learning outcomes and
Who is
see
the
what
winner? You can
was
see
the
it, I think.
see.
Yeah, share your screen again.
Okay. Let me see who's the winner.
Apparently, it's not me because I didn't answer the first one.
Okay, where do you get the winner from where? Okay. Somewhere.
Can you share your screen?
Yes, of course. Wait.
Thank you.
You're welcome. I don't know if it shows the winner. I don't think it shows the winner.
We can't. Yes. So this is your screen. We can't. Yes.
I don't think so. I don't think we can see the winner who is the winner. So
Really? Response.
no, I did
Go back.
respond. I remember maybe I said
The other tag responses, summary and responses. Yes.
you're not gonna see the winner.
Okay, it's anonymous. Okay, all right. Next time we can go we can try the another platform. I think it's called cohorts, something like that. I
I
forgot.
believe we have some competition here.
Kahoots. It's Kahoots.
Yeah, Kahoot is more.
Kahoots. We can try it.
This type of things. Yeah.
All right, good.
So we reached the end of the session. We hope you enjoyed it and learned something again. We value your feedback, so please tell us in the comments what do you want to change, what's your opinion about the session, any suggestion you have for the next ones. Your suggestions are gonna be welcomed, and please mark your calendar for the next MDS talk. It's gonna be next Wednesday at 9 p.m. Morocco time. Thank you so much, guys, for being here. And remember, if you believe in it, it's already yours. And go ahead, study, and reach your goals and dreams. See you later. Bye.